is same day. We just did the 424. Now we're doing the one that says 428. We combine these to a single day. So on the 428 page, we're still adding and subtracting rational expressions, but this time they have a different denominator. Okay, so that is what is different here. Different denominators. There is not a common denominator already done or already there for us. So we already know that a rational expression is a quotient. We said that on the last page of notes. A quotient or a division of two polynomial expressions. Okay, and we have these steps that we go through to simplify. Okay, now when the denominator is not the same, okay, to find a common denominator, okay, you factor the numerator and denominator first if they aren't already. You identify any common factors amongst the two denominators. Okay, so you're determining the least common multiple of the denominators, which is also the least common denominator. And you rewrite your expressions by multiplying each rational expression by a form of one of the, a fraction. Anything over itself is one, right? So whatever you have to multiply the denominators by to get them to be the same, you also have to multiply the numerators by, because you can't just change the value of the expression. So to keep it equivalent, that's why you have to, whatever you multiply the denominator by, you have to multiply the numerator by. Okay, once all of the expressions have the same denominator, then you're adding or subtracting the numerators. So then it's like what we just did on the 424 page of notes. Okay, so we've got this extra step here of finding a common denominator first. Okay, then the rest of these steps are the same as what we were just doing. All right, so let's put those kind of confusing words into action here. When I look at these denominators, I do not see this, they're the same. One's a 6 and one's a 5. So if I want to get them to be the same, I multiply them by each other. So I multiply the 6 times 5 and the 5 times 6, because that will make them both 30, won't it? Do y'all agree? If they both become 30, then I'll have a common denominator. Now, what this was saying up here, which kind of sounded confusing maybe, is you multiply each rational expression by a form of 1, a fraction where the numerator and the denominator are the same. Okay, so we're not just going to multiply the denominator by 5 here. We have to multiply the numerator by 5 as well. 5 over 5 is just 1. So multiplying this by 1 doesn't really change the value. Okay, it's like changing a 1/2 to a 2/4 or something. It's still equivalent. It's just not reduced. Does that make sense? Now we have to do the same thing on the other side. The note pages are over here. You need both pages. Okay, so over here we multiplied the denominator by 6, so we have to multiply that numerator by 6. All right, so once I do that, now I've got on the left side 8 times 5. What's 8 times 5? So we've got 40x over 30, my new common denominator. And over here, 6 times 6, we've got 36 over 30. So now that I have a common denominator, I can combine the numerators. We would be doing 40x plus 36. This would all be over 30. Now, the top can be factored. So I'm going to factor out in that numerator a 4. Okay, so 4 can be factored out up there, which would leave me with 10x plus 9 is all over 30. Now, the reason I did that, now that that 4 is factored out, I can see if the 4 over 30 reduces, which it does. Okay, 4 doesn't go into 30, but what does? Go into both 4 and 30? A 2. So I can reduce that by a factor of 2. So that would be 2 times 10x plus 9 over 15. I had to get a common denominator first. Then I did what we did on the last page. And on this one, once I factored, I was able to reduce. Okay, so on this one, to get 2 and 3 to be the same, I would have to multiply this side by 3/3 and this side by 2/2. Because I'm trying to multiply those denominators by each other, right? By the least common multiple of them. The least common multiple is going to be 6. I'm turning them both into a 6. So now this is going to be the numerator over here, 3 times 20, or 3 times 7 is 21. And then we've got our minus, and then 3x times 2 is 6x. Now I've got a common denominator. I'm going to combine these. It's going to be all together over 6. We're doing 21 minus 6x. A 3 can factor out of 21 and 6, right? So that would be 7 minus 2x that you're left with. And then the 3 over 6 reduces to 1/2. You don't have to write the 1. If you want to put 1 and then keep that in parentheses, you could, but this is how I would write it. Okay, so again, we are reducing these fractions. We were able to reduce on both of these. So far, so good? Okay, so that's with basic numbers as your denominators. Okay, we were getting the denominators that were just numbers to be common. Now, if you look at the back, okay, these get a little more complex. What if our denominators have some variables now? Okay, so let's take a look at this first one. So here, my denominator is 3x, and here it is 5x. So they both have an x. They have, bless you, they have the same variable to the same degree, so that's good. It's just the coefficients that I need to get to match. So in this one, again, I just have to multiply by the other coefficient. So I have to multiply the 3x by 5, which if I do it to the denominator, I have to do it to the numerator. And on this side, I have to multiply the 5x by 3. So that's going to give me a common denominator of 15x. In my numerator over here, 5 times 10 would be 50, and 7 times 3 would be 21. So now I'm going to combine these. 50 minus 21 all together over 15x. And then I just do that subtraction. Okay, what's 50 minus 21? 29. Okay, over 15x. 29 over 15, they don't have a common factor, do they? 29 and 15. So we can't reduce there. So we're left with 29 over 15x. Can't reduce that. All right, now this one's even tougher. The second expression, the second term, the one being subtracted, isn't even written as a fraction. If it's not written as a fraction, what's it understood to be over? It's understood to be over 1. So my denominator on the left is x plus 4. My denominator on the right is 1. So if I want these to be the same, 1 times anything is whatever it is you multiplied by, right? So if I want to change this to a 4 or a x plus 4, I would just need to multiply by x plus 4. So this side is going to need to be multiplied, the denominator and the numerator, by x plus 4. I don't actually have to multiply the left side by anything. Okay, I've been multiplying them by each other, but if I multiply by 1, that doesn't change anything, does it? I don't need to show multiplying by 1. All right, so let me go ahead then and rewrite. I've got 5 over x plus 4 minus. All right, so now I've got 2x is being multiplied by a binomial, by an x plus 4. So it has to be multiplied by both parts. So that becomes 2x squared plus 8x over x plus 4. So now I've got my common denominator, and I'm going to subtract. So again, I can distribute that negative here, or I could rewrite this and distribute the negative, or some of you up here may have done the negative with the 2x when you distributed. You could have done it up there and done this all in one step. Okay, but I'm just showing you the 2x had to be distributed and the negative has to be distributed. Yes, you could have done it together if you wanted to. And when we combine this, then we have 5. Then that would be minus 2x squared minus 8x. All together over our common denominator of x plus 4. So now I am simply going to rewrite this numerator because it's a trinomial. It's a quadratic trinomial. You have an x squared, you have an x, and you have a constant, but it's not in standard form. So if I rewrite this in standard form, I would write the negative 2x first, minus 8x, and then that would be plus 5. So I didn't change anything. I just rearranged it here. But if I do that, I can now look and see if I can factor this numerator. Okay, so you can try. I'm not going to take our time to do it. It does not factor. Okay, so I'm going to save us the time and tell you that this does not factor. Because the only factors of 5 are 5 and 1. And then the factors of 2x squared would have to be x and 2x. And when you try the different combinations and orders, there's no way to get the negative 8x in the middle. So this does not factor. So that's as far as I can take this one. So far, so good? Let's do another one kind of like that, except this time there's not a 1 for a denominator. So one of the denominators is just a variable. One of the denominators is an expression. We need to get them to match. If it helps you to put parentheses around your expressions, put parentheses around them. But we need to multiply these denominators by each other. I can't just put plus 7 on this to make it the same. That's not how this works. You have to multiply, not add things. So I'm going to multiply this by x plus 7. And what I do to the denominator, I have to do to the numerator to keep this equivalent, because technically I'm just multiplying by 1. Now, if I do that to the right rational expression, the left one needs to be, that's going to be x times x plus 7. I need this to be the same. So this side needs to be multiplied by x. All right, so when I do that, over here on the left, x times x would be x squared. Now I could go ahead and combine the minus and the 3 and get it all distributed at once, which is what I would typically do. So that's going to be minus 3x minus 21. And this is all together over x times x plus 7. Notice I'm leaving my denominator in this factored form. I'm not going to distribute that x because then I just factor it back out later. Because remember, we want the numerators and denominators in factored form so we can see about reducing. Okay, so I leave the denominator factored. Okay, and now I look at the top and ask myself, okay, can I factor this numerator? Okay, a is an understood 1, so that's the easier type of trinomial to factor. And I ask, what are the factors of negative 21 that would add to negative 3? Are there any? So you could look at that purple reference sheet I gave you with the list of factors and go look at the list of factors for 21. It's 21 and 1 or 7 and 3. None of those would combine to give you 3, would they? So this is not factorable. This is as far as I can take this one. If you want to make a note on those last two that we had the trinomials and just put a side note and be like, this trinomial can't factor, that's why we didn't. Okay, or if you'll remember that, that's fine. All right, in this last one, we're going to do the same thing. I'm going to put parentheses around my expressions, and then I'm going to do my multiplying to get a common denominator. So this side's going to be multiplied by x, because that's the denominator of the other side. And this one's going to be multiplied by x minus 1. Okay, so x times 3 will be 3x. And then this is a negative 2 or a minus 2 being distributed. So that'll be negative 2x. That'll become plus 2. Over my new common denominator of x times x minus 1. And I'm leaving it factored. Okay, there's no reason to distribute if I'm going to try to factor the numerator and denominator anyway to cancel things out or reduce. So now I'm going to rewrite the top. I'm going to combine like terms up there. 3x and 2x. 3x minus 2x, that's just going to be x, isn't it? And then there's no other constant, that's just plus 2. And then my denominator, I will leave factored. We have x and we have x minus 1. If it is helpful to you, anytime you have an expression like a binomial, to put it in parentheses, that x plus 2, if that helps you see the x is attached to this plus 2, I cannot reduce it with this x out here. Okay, put parentheses if it helps make that clear. So nothing here can reduce because I've got an x and an x minus 1 as factors in the denominator, and I've got an x plus 2 as a factor in the numerator. So none of those are exactly the same. I can't reduce it any further. So I can leave it like this. Okay, or technically, if you wanted to go ahead and distribute that x in the denominator, you could, but it's not necessary. Okay, so that's adding and subtracting rational functions. The first page was real basic. The common denominators were already there for you. Okay, this second page got a little more complex. We had to get common denominators first. Okay, I'm going to open a Delta Math practice over this, but since we really don't have any class time to work on it, I'm going to give you an extra day to complete it. I'll just give you till the end of the week. I'll just not make it due till Friday. Okay, since we didn't really have class time to work on it. Okay, so there is a practice over this, adding and subtracting. Okay, but it's not going to be due until Friday. And tomorrow, we're going to keep talking about let me pull up the calendar again. You can see we keep talking about adding and subtracting rationals tomorrow. Okay, so there may be some things in this practice, if you start to do it today, you may be like, that doesn't look like our notes. We didn't do ones like that. We're probably going to do ones like that tomorrow. So I'm kind of combining all of these adding and subtracting types into one assignment. So the assignment might be a little bit longer, but you're going to have until the end of the week to do it. And it's really covering 3 different pages of notes, okay, in one assignment.